I've always felt like there was something magical about Delta 3D printers. From the time I got into 3D printing many years ago, even till now, having been around lots of different 3D printers, I never get tired of watching the three-armed kind of robotic spider whipping around laying down plastic. And like just like any other 3D printer, Delta 3D printers have evolved a ton over the years, which is a great thing. Delta 3D printers have always been known to kind of be tough to calibrate, and I can personally vouch for this, as the earliest Delta printer that I got was probably 5 to 6 years ago, and putting it together was a pain. Getting the bed level was nearly impossible, and just to get consistent printing was an incredible chore. Luckily, with the evolution of hardware, software, the firmware side of things, this has gotten much easier, and putting together a Delta printer and their consistency has gotten a lot better along with all that. One of the biggest pluses of Delta 3D printers is that they have been known to be able to be pushed to print faster than their standard Cartesian counterparts. And this is due to a couple things. The first is a stationary bed, the second is their incredibly rigid frame, and the third is their light gantry. So unlike on most printers or like a Prusa style where the bed goes forward and backwards, or a different style where the bed drops up and down, on a Delta printer, the bed is just completely stationary. It doesn't move in any direction at all. And you've got the three arms that are typically made out of anything from plastic to aluminum to carbon fiber that are very rigid, and it allows the gantry to whip around very quickly, but also to maintain a lot of accuracy. And although there are some Delta printers out there that do come with a direct drive, it's not nearly as common, because with Deltas, and again, normally one of their biggest pluses is speed, having a Bowden system in most cases makes more sense, because having that stepper motor and the extruder off of the gantry allows for it to just whip back and forth a lot quicker. Flsun is a 3D printer manufacturer that's come up over the years, and they've been known to make some pretty high quality Delta printers with a low price tag on them. And about a year ago, I reviewed the Flsun Q5, which was a small Delta 3D printer that was really impressive to me, and had definitely been my best experience with a Delta printer thus far. And they reached out to me a few months ago saying that they had a printer in the works called the SR, or the Super Racer, and asked if I'd be interested in testing the machine out. Well, all it took was for them to give me a list of the specs, which had me drooling and me saying, hell yes, absolutely, I would love to test out this larger Delta printer when it becomes available. So over the past month here, I've been playing around with the SR, which is this big printer right behind me. And in today's video, we are going to cover the specs. We're going to talk about my whole experience with setup and calibration. I will, of course, show you guys any prints that came off the machine. And finally, I will give you my sort of summary or my final consensus on the things that I like or the things I don't like so much about this printer. So that way, hopefully, you can decide whether the SR is a printer that you might be interested in. There is going to be a ton to cover, and if you've been looking to get a Delta printer, or you've just been fascinated with learning a bit more about Delta printers, this is definitely going to be the video for you. So without further ado, let's get right into today's video. Per usual, we are first going to start off going over the technical specs of the printer. The SR has a print volume of 260 millimeters in diameter with a height of 330 millimeters, which is a pretty large Delta printer. This is thanks to the machine's footprint, which is a 440 millimeter by 390 by 960 millimeter overall footprint for the printer. This works for me because I have much more height to work with in general than table space. It uses a Bowden type extruder, which is a BMG clone, and honestly, compared to a lot of other budget 3D printers out there, this is not a half bad extruder to come stock on this machine. As for the hot end, it uses what looks like a clone of the E3D V6 Volcano, but it is not all metal. I really do like this decision, and that larger heater block will really help to push filament through the nozzle quickly. The bed surface is the same as on the Q5, which is a glass ultra base style bed, and aside from having a good flex plate system, this is definitely going to be second in line for me as far as my favorite build surfaces. The machine is constructed of heavy duty aluminum, and all the axes ride up and down on linear rails, making it a very rigid machine. I was actually really surprised that the arms on this printer are made out of carbon fiber, since that is something you see more on premium Delta printers that are much more expensive, and that is definitely going to help with our overall goal, which is having a very light and stiff gantry. The printer comes with a filament run out sensor as well as power loss recovery. It is a 24 volt system with a 32-bit board that is running on Marlin firmware. For interfacing with the printer, you can print over your traditional USB, or you can use a micro SD card and print over the included touchscreen. The touchscreen is held in place by a magnet, and it has a spiral cord which allows you to take it off and bring it towards you. At first I wasn't sure how I really felt about this, but I have to admit that it works pretty damn well. The printer does have automatic bed leveling, which you will plug into the gantry attached to the nozzle and let it run its mesh. Once completed, you will go ahead and disconnect that, and you can store it, at least I did, I stored it in the compartment that is built into the printer. I am happy to admit that after all of the prints that I ran on this machine, it is nowhere near becoming unlevel. And the beauty of this, again, comes back to the Delta printer and that the bed is completely stationary. There's no springs, there's no movement. So you really shouldn't have to re-level this bed very often once you set it. The printer uses TMC2209 stepper motor drivers, and Flsun claims that the default printing speed is 150 millimeters a second, with the max printing speed being around 200 millimeters a second, which is roughly 3 to possibly 4 times quicker than I normally print on my other 3D printers. Before assembling the printer, I did go ahead and disassemble it a little bit more and remove the panel so that way we could take a look quickly at the main board and the electronics. I do feel like the cables could have been cleaned up a bit more with some zip ties, but this has to be the most space I've ever seen a mainboard have. Since the panel is so large and the power supply is on the other side of the printer, there is a ton of empty space. This, in combination with the built-in board fan, should help to make sure that both the controller and the stepper motor drivers stay nice and cool. And if you are looking for a place to stash a Raspberry Pi for running something like Octoprint, you will have no problem finding space inside of the printer to do so. Now that we've covered the specs on the machine, let's talk a little bit about the assembly process. The Flsun SR showed up in a pretty large box, which makes sense considering its size, and it was very well packaged. I am happy to state that it came with a printed guide on how to assemble, it had a PDF guide on how to assemble, and it also had a really nice video taking you along with the assembly process should you have any questions or anything was unclear in that printed guide. I had no problem following along with the printout guide, but I do think that having multiple points of reference is always a positive thing. I didn't exactly time myself as far as assembly goes, but if I had to guess, it was somewhere between 30 minutes to an hour. Granted, that was with me doing a lot of recording, and that adds an additional time, so your printer assembly may vary, again, depending on whether you've assembled a printer before or kind of what else you got going on, but between half an hour to an hour sounds about right in what you can expect for this build to take. I'm not exaggerating when I say that this is probably the most rigid machine I have ever had or ever put together on the channel. Not only in weight, but these massive aluminum beams just make it incredibly solid, which is really what we want. If this thing is going to be pushing those speeds that they're claiming, we absolutely need to make sure that our frame is stiff, and that added weight will just help to kind of mitigate any vibrations or things of that nature. So I, again, was very impressed with how well and just the level of kind of quality that these components had compared to a lot of the other printers, especially in the Delta category that I've tested out over the years. Once assembled, I went ahead and turned on the printer, homed the printer, attached the bed leveling, and let it do its quick little mesh, and I was ready to print. I would say from the time it was turned on, from plugging in, running the mesh, and putting it away, you'll be up and running within probably 5 to 10 minutes. The printer does come with 200 grams of white PLA, but I opted to use some blue PLA that I had laying around, and like I traditionally do, I plugged in the micro SD card to see if there were any pre-sliced files. There was a couple, so I printed out one that was sort of a rectangular cube that was only half full, so it showed you the infill on the top. It was kind of an interesting choice. And then another one that was of a nut and bolt. And I know that they said 150 millimeters a second, so I sort of should have known what I was getting into, but I've never seen a printer print as fast as like the default files that came on this printer. Sure, I've seen people push their printers online. I've seen, you know, people that kind of tune very rigid, either DIY machines or something of that nature to print very quickly, but hearing that the machine prints at 150 millimeters a second and watching it in front of you is two very different things. And I was it was a combination of excitement and almost fear just watching this thing whip around, printing out especially the bolt with how quickly it was printing out. Once those parts were completed, I plugged the micro SD card into the computer and I installed the Flsun Cura, which I believe was Cura 4.4, so a little bit older version of Cura. And Chelsea at Chaos Cortec ended up releasing a model of Doge, which I had a spool of silky gold PLA, which I figured would be perfect to print this out in, and it turned out absolutely awesome. Links to anything that I talk about or print in this video will be in the description if you want to check them out as well. And then while I was doing that, Chelsea also released a couple of different Mother's Day models. One of them sort of had this almost organic geometric flow to it, and it was taller versus wider, which I felt was perfect for the overall size of this printer. So I went ahead and sliced it up, hit print, watched the first couple layers go down, and came back to a print that was halfway done and paused. And I thought I had more filament of this Protopasta HTPLA, but I was wrong. Luckily, the Filament Run Out Sensor did exactly what it was supposed to do. It paused the print, I loaded up some other Protopasta PLA and hit resume, and the print was able to complete. Now, I will say that the HTPLA print turned out, in my opinion, okay. It wasn't a bad print, but there was definitely some under extrusion. I don't know if this was attributed more just to the HTPLA needing a slightly different profile, because I hadn't noticed that in any of the PLA prints, but if I were to print this again or use HTPLA, I would go ahead and bump up the temperature slightly from the 220 that it was at. Again, with those speeds, you really might need to crank up some of the temps to kind of offset the amount of filament it's trying to flow, and I would possibly lower the print speed from 150 down just at least a little bit to kind of help it out. But I hadn't noticed it again with any of the standard PLA filament that I'd used or in any of the other prints that I do with the SR. Next, I wanted to print out the Modbot robot mascot. I had seen someone over in the Modbot Army Discord that had printed one out using tree supports and figured, hey, that'll be perfect. So I went ahead and again, imported into their profile in Cura. I left everything default at those crazy quick speeds. I added tree supports and I hit print. Everything was going great. And then at about 70%, the part came off of the bed and I was sad. So what I ended up doing was I just took some glue stick, put some glue stick down to give it a little bit more adhesion, and I didn't change a single thing on the profile and hit print again. This time it made it about 90% through the print before the exact same thing happened and it dislodged from the bed. One thing I found incredibly interesting about the profile that Flsun released with this printer was that the default infill setting was set to gyroid. And I know a lot of people love the gyroid infill. It looks awesome for time lapses. It's just a great infill. However, when you're printing at 150 millimeters a second, there's no way that gyroid infill would be my first choice. And the reason for that is that gyroid infill basically waves back and forth. And so you have to think that if you're going at 150 millimeters a second and you're waving back and forth, that's going to create some insane vibrations. And that was definitely the case with this. The vibrations from the head moving back and forth, like at those rapid speeds, were what was causing this part to dislodge. And so I kept all of the settings the exact same, and I swapped over from the gyroid infill to your standard kind of grid infill, which is a lot of the times what I use. I hit reprint and it had no problems completing. The printer was one, way quieter, and two, just had way less vibrations, and the part stuck down like a champ. So I think it's a really interesting choice that they chose gyroid infill. And again, aesthetically, does it look cool? Yes. Is it strong infill? From everything I understand, yes. But if you're printing at those speeds, I just absolutely would not recommend using gyroid infill. Next, I ended up printing out a small extruder knob, and with this print, I noticed something really interesting. As it was getting towards the center portion of the extruder knob, which was really thin, and the part was, again, just whipping around, every single layer, the hot end would go to a specific location and it would stall just for, I mean, a second maybe. And while it stalled, a tiny bit of filament would come out and then it would continue. And so, one, it was adding time to the print. Two, it was possibly making the print less nice looking because of the fact that those blobs were coming out. And so I was really unsure as to what was causing it. It seemed like I didn't know whether it was, I figured it was probably a either hardware limitation, maybe just because of how quickly it was moving. Even the 32-bit was having some issues keeping up with the motion, or maybe it was something to do with the firmware, a firmware setting. So instead of doing a bunch of guessing, I decided to reach out to the community. I posted on Twitter what was going on. I follow, and a lot of people in the 3D printing space follow me, and some of those guys are crazy smart, and guys and gals. And so I did get a lot of feedback and wanted to say, one, thank you to everybody that did reply with your thoughts, and I ended up figuring out the solution. So originally someone said, hey, I think it could just be your micro SD card, either format it or try a different micro SD card. Perhaps, you know, it's a low-cost micro SD card, it's just not being able to read and write quick enough to the printer while it's printing. So I did both of those things to no avail. And then Kirsty Fabrications, as well as somebody else, and I apologize, I forgot your name, said that they believe it had to do with the power loss recovery. With the power loss recovery at each layer, it's actually saving its current state to the micro SD card, so that way in the event of a power failure, it would know where to resume. And so Kirsty sent me over a Marlin wiki page that basically had the G code, so that way I could disable it. I went into Cura Slicer, the starting G code, and pasted that little snippet in there, ran the print again, and it did not stall at all. So it definitely was related to the power loss recovery. It is my belief that it's something that you won't see with the larger prints, which is why I didn't notice it, because it seems like to write its current position or its current layer that it's completing, it takes a certain amount of time to do so. And so on a larger layer, because it's printing that larger layer, the micro SD card and the printer has more time to communicate with each other, and by the time that layer is done, it's already written what it needs to. However, on a small part where it's whipping around and each layer is only taking a few split seconds, it doesn't have enough time to write that state, and so it has to stop for a quick second, finalize that state, and then continue the next layer. So by disabling that, I was able to completely get rid of that little blip that was happening every layer, and wanted to definitely share that with you guys, because I'm sure if you end up getting the SR, that is something you may experience as well. Now, full disclosure, this is something that I think Flsun should have QC'd or known of if they did not know of it before releasing this printer. For me personally, I've never really used power loss recovery. I think that in the 6+ years I've been printing, there's one time where I really printed out a big model that needed it, and there was a brownout or something like that where the power reset really quickly and it came in clutch. But for me, it's not a huge deal. Most of the things I'm printing, like, it's not that big of a deal. I'm fine with disabling it, but I am hoping that there is able to be some solution to this, and I'm at least happy that the workaround for this is quite simple. And again, just if you paste that one line of G code into the starting G code, it disables it, and you don't have to worry about any sort of stutters in your print. Next, I went ahead and printed out a 2-part headphone stand. It basically was a bolt and a little headphone mount that you can bolt onto your desk to place your headphones on. It printed out really, really well, and even at the 150 millimeters a second, the bolt and thread screwed in super smooth without any problems, which again is attributed to just how rigid this frame is. It's able to whip around very quickly and still have that high level of precision that you want. Then for fun, which I don't normally test printers for this, but I did throw a little bit of TPU filament at the SR, more for shits and giggles than anything really. And I did slow down the printer to about 30 millimeters a second, and I did disable retraction, and again, the TPU parts were basically little cable ties that weren't exactly the most intricate, impressive TPU parts, but with this long Bowden setup, this is definitely not what I would consider the ideal printer setup for printing flexibles, but the parts turned out pretty good. I mean, honestly, the fact that they completed and they were certainly usable, and I didn't tune, like, I did very little tuning. So if you wanted to print with flexibles or certain TPUs, I do think with a bit more tuning, you could certainly get better results than even I got, but it was reassuring and just cool to see that, hey, even on this printer, you can do a little bit of flexible printing should you want to. So there are a lot of things I like about the Flsun SR, and at a current price tag showing of around $450, I think that that is a steal for just really how much machine you are getting for the price. There's definitely a lot of impressive things, the things like the linear rails, the carbon fiber rods, and a 32-bit board, and they certainly did not cheap out again on the construction of this machine. It is, like I said, the most rigid printer I've ever had in my hands. However, like any machine that I get through here, it is very rare that we have a machine that I deem perfect, and there are some things that I think are worth talking about. The first, like I mentioned a second ago, is the issue with power loss recovery. It certainly is something that I am not super stoked on, and the fact that it does cause little blobs on small parts is something that needs to be addressed. Either they should just sell the machine as not having power loss recovery and disable it in firmware, or something needs to be optimized or tuned to where that does not happen. I don't know. I won't pretend to know the answer to that. Right now, I'm just going with the disable option, and that works for me, but I do think that Flsun should address that. The second thing is the machine has TMC 2209s, which are silent stepper motor drivers, but this printer is anything but silent. It is a very loud printer, and that is something that you should know. And the loudest aspect of it for sure is the extruder. It's using a like full-size NEMA 17 stepper motor, and because its default print speed is 150 millimeters a second, you have to imagine how quick those retractions need to be for it to be able to actually print at those speeds. So I think I recorded a snippet, and if I did, I'll place it in here. But the sound of the extruder going back and forth the whole time it's printing at those quick speeds is noisy. Also, because it's whipping around at such quick speeds, with that gyroid infill, although the machine itself is rigid, the head on it just vibrating back and forth at 150, I keep saying 150 millimeters a second because it's very impressive to me. But the head moving back and forth while doing that gyroid infill creates a lot of vibration. And although it doesn't seem to translate into the part, and I think that the springs on here actually help a bit to absorb that, that vibration, it is audible, and it is definitely worth mentioning. Switching over to the grid pattern did seem to alleviate a lot of that, and prints did become quite a bit quieter after that, but I still wouldn't describe this printer, if you're gonna be, using it to its full potential at those speeds, as a quiet machine. It's just not the case. And the last thing, which is quite small, is just with the touchscreen. The touchscreen is not a bad touchscreen. It's bright, it's very responsive, but it makes sounds. So every time you touch something on the touchscreen, it makes a loud beeping sound. And most 3D printer touchscreens that I've seen, or just screens in general, have the ability to disable the beeping sound. You could probably open this up and rip it out, but most of them just have a setting, sound off, yes, it disables it. There's no way as of right now that I've seen, and I've gone through every menu like 3 times, to disable the audio. And granted, like I said, the rest of the machine itself's not quiet, but when I was here trying to start a print late at night and trying to be as quiet as possible, the beeping got old very quickly. So small thing, but again, a little bit of an annoyance to me, and I think it is worth at least stating that. In my opinion, there is no doubt that the pros far outweigh the couple of cons that I mentioned on this printer. And if you're looking for a sub $500 Delta 3D printer, I think that this really is the winning ticket. A lot of the specs, the size, and the features of this Delta printer are common on printers that are between 50% to twice the price of this machine. So like I said, for the price point, it's just, to me, the value proposition is really there. I am really excited to have the Flsun SR in my line of 3D printers, and being that I am a content creator, having that stationary bed, which I didn't mention earlier, is beautiful for time lapses. Yes, you've got things like Octoprint and Octolapse, but just being able to pull out a camera and hit time lapse and have the bed be stationary makes for some really, really sick looking but simple to set up footage. Now, as far as upgrades go, there's not much that I think that I would actually do to this machine. If they come out with an update for the screen that gets rid of that beeping sound, I will certainly do that. And if they come out with a firmware update that helps to fix the issue with the power loss recovery and that little bit of stuttering, I would also do that. But aside from that, the flex plate system could be the only thing I see in this printer's future. I'll be primarily using this for PLA and some PETG, and so a flex plate system is just really the winning proposition. Last thing I just want to say is that I am glad that the specs that Flsun had sent to me many, many months ago lived up to the expectations in my head. And again, I think that they really did a great job on making an impressive machine at a price point that is much more attainable than a lot of the other Delta, larger Delta printers on the market. So this has been the Flsun SR. If you have any questions about anything I discussed or didn't discuss, let me know in the comments down below. And if I don't know the answer, I can reach out to Flsun directly and get that answer for you. Don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. If you did want to support the channel furthermore, I will place links down below in the video description over to my Patreon, where there are some really awesome rewards. Huge thank you to all of my current Patreon supporters. I really appreciate each and every one of you, allowing me to spend more time doing what I love, which is coming back each and every week and making content for you guys to enjoy. On that note, this has been Daniel from Modbot, and I look forward to seeing you guys in my next video. Peace, guys.